Hello, I'm excited today to take this nice example. It will cover all the three videos that we talked about. We talked about parallel, series, switches, and the bag of tricks. So, if we look at this example, there's a switch, and he asked me to find Vx and Ix. There's the Ix, and there's the Vx. And he also asked me on two times, t less than 0 and t greater than 0. Always, if you have a switch, step one is to draw or sketch the uh, switch at the first time. So when t less than 0, that means the switch would be directed toward the tail, and the tail is to the left, right? And then after the time 0, it will go to the right. So if I draw it, it will turn out to be something like this, right? Since this wire is in the air, that means I'm gonna cancel it. So this is cancelled until here. Okay, how about this one? Do you remember, do you recall the first trick? We mentioned the first trick and it was about, let's see here. The first trick was about this wire. Even if it holds a current source or whatever, a resistor or a voltage source, it's always, since there is only one wire between those two loops, that means it will be cancelled. So I'm gonna erase this wire. If it's erased, this will look something like this, right? So this loop is separate than this loop. The only connection between them is this dependent source. Why? Because we said the dependent source would depend on a value in the circuit, and this value is, it's 3 times the current IC. Where is the current IC? It's here on the left side. So whenever you find IC, you go and find 3IC, which is the value of the voltage source. So if I want to start up to the with the right loop, I can't. Why? Because I don't have that value of the IC. So I go look for the IC, I find it here, then it's smarter to start from the left loop. I have an independent source, so the value of the current is 4 ampere. Usually step 2, I would go and name the nodes. This is node number 1. I would start it from the top end of the current source, move toward the resistor. This is node B, from this side of the resistor to the other side, and then I'm stuck because there's a resistor, and there's node C. Here there is D and then E. Now, after I name the nodes, what tools do I have that would help me out in solving this problem? First, always remember Ohm's law. Second, remember that the currents in series are equal and voltages in parallel are equal. If we look at this left loop, I have a current source. That means the current here, since the current is not splitting, it will be the same. So the 4 ampere, it will move this way, continue this way, continue this way, continue this way, without any separation or without splitting. That means if I'm not splitting, then the current here 4 ampere, here 4 ampere, 4 ampere, 4 ampere. Don't think of a resistor like it's swallowing any part of the current. No, it uses the current to turn on like a light bulb, but still the current still 4 ampere. So 4 ampere, that would tell us IC in series with the 4 ampere, then IC is a 4 ampere. And it's positive. Why it's positive? Since it has the same direction as the 4 ampere, so it's positive 4. Now, the current 4 ampere would go into the 6 ohm. If I'm having the current and the resistor, I can find the voltage. Vx would equal, according to Ohm's law, Vx will equal I times R. I is 4 and R is 6, so 4 times 6 is 24. Is it positive or negative? The current went into the positive side of the resistor. This means it's positive. Why? because we said the current would be absorbing, the power would be absorbed in this resistor. So I'm moving from a high potential to a low potential in a resistor. So that's correct. Then this Vx is positive. Now I'm done of the left side. He asked me for Vx. I see I only found it, so I can use it on the right side loop. Then Vx is what I'm looking for, 24 volt. Now I want to find Ix. How can I find Ix if I don't have the value of this voltage? Then I'm going to use the IC, which we found it was 4 ampere. I'm going to use it to find the value of the voltage or a current. Now, since there is a positive and negative sign inside this dependent source, then I'm talking about a voltage. Even if the value of it will be equal to 3 times the current IC. The IC here doesn't have any like authority to call this a current source. No, the positive and negative signs would call it a voltage source. So the value of this voltage source is 3 times the current IC, which is 4. So 3 times 4 is 12 volt. So this dependent source, so I said in step 4 I'm going to look to the right loop and I will use the current IC to find the value of the dependent source. If I'm having the value of the dependent source, which is 12 volt, that means if I'm looking at this, since I'm having here a node D and here E, the voltage here is called DE and the voltage here DE, right? We said voltages in parallel are equal. Then this voltage at the resistor 3 ohm equal to the voltage at the dependent source, which equals to 12 volt. Now, if this voltage is 12 and the resistor is 3 ohm, what is the value of the current? Again, I'm going to go back to Ohm's law. Ix equal V, which is 12 over 3. So 12 over 3 would give you 4 ampere. Is it positive or negative? Now, if I'm looking at this, those signs, positive and negative, is the same polarity as the dependent source, and they're both parallel. That means the voltage here is positive, negative, and the current is going through the positive, so the current is moving from a high to a low potential, and that is correct. So the current Ix is positive, has a positive value. Now this was the part A. For part B, if I'm looking at this circuit, that wire would move toward the right? So this circuit will be open. If this circuit to the left was open, if there is nothing here, that means the current IC is 0 current. If IC is 0, then the voltage 3 times 0 is a 0. If the voltage is 0, right away we said if a dependent source has a voltage of 0, then it's a short circuit, a wire, right? And that was trick number, let's recall that was trick number 3. We said in trick number 3, if a voltage source has a value of 0 volt, then it's a short. If a current source, then it's open. And in our case here, it's a voltage, so it's a wire. Now, after I'm having that wire, like I redraw the circuit, this is gone, so I erased it. This has a value of 0, so it's a wire. Now if we look at this circuit, I'm going to name the node again. This is node A. Why? Because if I keep my hand on the paper, I'm going to start here. I'm not moving my hand. I'm going to go down. I'm going to go back. I'm going to go to the right. And I'm going to go down here, 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 here. I stopped when I ended up at all the ends. Now if you look at this resistor, it has a node AA. We said in trick number 4, if you have the same node, that means this resistor will be erased. And that was trick number 4. Let me show you again. Here we said if it has the same node, the resistor that has the same node will be cancelled. So again, if this resistor is cancelled, what's the value of Ix? Is 0. Okay, if Ix is 0, if we looked here, Ix is 0, this is gone, this is a short circuit, so we're left with, if I erase this, then you only have this loop, right? The current 2 ampere is going all over this loop. So if I'm having the current 2 ampere and I have the resistor, I know the voltage V would, using Ohm's law, 6 times 2, which is 12, right? So 12 volt. Is it positive or negative? Look at this current is going through the negative sign, the negative side of the resistor, moving from a low to a high potential, and this is totally wrong. A resistor has to have an absorb power. Absorbing power moves from a high to a low potential. In this case, since he gave us the Vx positive up and negative down, that means it's in a wrong direction or wrong polarity. So I'm gonna call it negative 12 volt, and this is our answer to this question. And we said the negative sense the current had entered the negative side of the resistor, and that is wrong. So this is the end of this problem. I'm gonna discuss another problem about the same subject. It's important to pay attention to those tricks. The signs is important. The dependent source when it's 0, how to draw it. The short circuit, what would it do to the resistor? So like you can watch this video one time, two times, and then try to solve the example by yourself without looking at the video. And that would be it for this session. See you next time. So have a good day.